Hello. Now let us talk about in-plane principal stresses. Now let me begin with this. Now from the previous classes we knew that if we have a point and we know the stresses, right? We know these stresses sigma x, sigma y and tau xy. It is what? It is with respect to a certain coordinate system, right? For example, if this is x plane and this is y plane, then this sigma x, sigma y and tau xy is with respect to x and y, okay? And then we talk about if we rotate a plane, okay? If we rotate these planes, if we transform, for example, if this is the plane and it is inclined at some angle of theta, right? Then we know that there will be normal stress on this red plane and there will be also a shear stress on this red plane, okay? And let us say this plane is with respect to x prime and y prime, okay? Then we know these stresses. This normal stress is going to be sigma. For example, let us say this is x prime and this is y prime. Then this is going to be sigma x prime and this shear stress on the red plane is going to be tau x prime y prime, okay? Then we knew this sigma x prime, it is equal to sigma x plus sigma y divided by 2 plus sigma x minus sigma y divided by 2 cosine of 2 theta plus tau xy sine of 2 theta, okay? What is this? It is the shear stress on this transformed plane, okay? And it is with respect to the x prime and y prime, okay? And we know the shear stress on this tau x prime y prime, it is equal to minus, here it was plus, right? Sigma x minus sigma y divided by 2 sine of 2 theta plus tau xy cosine of 2 theta, okay? Now we know these stresses on this inclined plane or transformed plane, okay? So from this you understand that this sigma x prime, or in fact this tau x prime y prime, they are what? They are functions means they depend on what? They depend on sigma x, sigma y, tau xy and theta, okay? So sigma x, sigma y, tau xy and theta. Similarly, this tau x prime y prime depend on again sigma x, sigma y, theta and tau xy, okay? So this is also a function of sigma x, sigma y, tau xy and theta, right? Now if we keep this constant, okay, if we keep the stresses constant, okay, constant, it means sigma x prime is only a function of theta and tau x prime y prime is only a function of theta, right? So it means if we change the angle of theta, the normal stress and shear stress on these transformed or oblique planes or rotated planes, whatever you call it, it will change, okay? So if I draw a coordinate axis, this is the values of theta and this is tau x prime y prime. So it means with theta, tau x prime and y prime, or in fact first we will talk about sigma x prime, right? It will change, okay? So for example, at some theta, for example, let us say this is the value, okay? At this theta, okay, the value is this, right? For example, let us say then at this theta, the value of sigma x prime is this, right? And for example, let us say at this theta, for example, let us say the stress is this. This is just to make you understand, okay? So if we join these, for example, let us say it is like this. It means at some theta there is going to be a minimum value, right? Because this is the lowest value, this one is the lowest value of sigma x prime and this one is the maximum value of sigma x prime, and it is at certain theta, and this is also at certain theta. Okay, so this one is sigma x prime max, maximum, and this thing is sigma x prime min, minimum, right? So these sigma x prime and sigma y prime, sigma x prime maximum and sigma x prime minimum, we call them as sigma x prime max and sigma x prime minimum. We call these as principal stresses. Okay, so we call this maximum stress. Okay, so this thing is one principal stress. We denote sigma principal stress with sigma p. Okay, sigma p for principal. Okay, so this is sigma p max, and this thing is sigma p min. Okay, and in a convention in the textbook of engineering mechanics or strength of mechanics is strength of materials or mechanics of materials is we denote sigma p max with sigma p1 and sigma p minimum we call it as sigma p2. Okay, so sigma p1 and sigma p2, they are what? They are principal stresses. Okay, and the plane where these exist we call them as principal planes. Okay, the planes where these exist we call them as principal planes. Okay, and the angles, this angle, this maximum angle at this angle and this angle. Okay, it is not necessary here is going to be minimum. For example, if the stress is like this, maybe this thing is maybe this thing is maximum. For example, like this, it is not something fixed. Maybe this is going to be at this we will have maximum, and at this we are going to have minimum. Okay, so what I want to say is that these angles where these maximum and minimum, I mean the principal stresses exist, we call them as principal angles. Okay, so in summary, if I summarize this, so what I mean to say is if we have a body, okay, and this sigma x, sigma y, okay, they are constants. Okay, so this is a constant, this is also a constant. Okay, and this shear stress tau xy, if we also keep it as constant. Okay, so let me draw these first. So these stresses are with respect to this, for example, right? Let us say this is x-axis and this is y-axis. Okay, and then if we have some plane, for example this, okay, and if we rotate it, okay, if we for example rotate it, okay, let me also draw their stresses. Okay, let us say this is sigma x prime, and let us say this is tau x prime y prime. Okay, so if this is the plane, and if we rotate if we change the angle, so it is going to rotate, right, because of we change the angle, right? So if we change the angle, what is going to happen? This sigma x prime and this tau x prime y prime will change. Okay, and at some angle we don't know right now. Okay, we just know we call them as principal angles, right? We call them as principal angles. Okay, so there will be some angle at which this sigma x prime and tau x prime y prime is going to be maximum, and at some other angle this sigma x prime and tau x prime y prime, it is going to be minimum, right? So we call those angles as, for example, let us fix the position. Let us say we found this. Okay, at this position the sigma x prime is maximum and tau, let us say this is the angle, so we call it as theta p, right, principal angle, because let us assume that at this angle we have this maximum. Okay, So this theta p, and this is the plane, principal plane, okay, because this is the plane where we have the maximum of sigma x prime, okay, but since it is the maximum, so we will not call it as sigma x prime, we will call it as sigma p, okay. So this plane, the red line, this plane is called as principal plane, okay. This theta p, it is called the principal angle, okay, and because this is the principal stress, we call it as principal stress. This is the maximum stress, normal stress, we call it as what? We call it as principal stress, okay. Now let us find the value of principal angle, okay. So when we know the principal angle, what is the exact value of principal angle, we will know exactly where this plane exists, okay, and then we will also find the value of sigma p, okay, sigma p1 and sigma p2. Now right now you can only see sigma p, only one maximum stress, right, but I will show in a moment. When we find the angles, we see there are basically two values of sigma p, sigma p1 and sigma p2, and we will see where is the sigma p2, okay. There is another plane, okay, there will be sigma p2, okay. So we will understand that when we find the angle, okay. So let us find this theta p, okay, let us find this and we will know more about it, okay. So to find the theta p, so what is theta p? At theta p we have sigma x prime, it is equal to sigma p, right, principal stress, right, and at theta p we have, at theta p sigma x prime is maximum, right, but we see here sigma x prime is a function of theta only if we keep these things constant, okay. So sigma x prime is a function of theta, right, and if we put theta, if we put here theta p, right, we are going to get what? We are going to get sigma p, okay. Now it is the maximum stress, right. Now if in from mathematics, from from calculus, we know if a function, if there is a function, it depends on one variable, right, and for it to be, for sigma x prime to be maximum or minimum, what is the condition in mathematics? The condition is differentiation of sigma x prime with respect to that variable d theta has to be 0, okay. So if something is maximum at some angle, then differentiation of that with respect to that value has to be 0, okay. It is from the mathematics, okay. So but we know sigma x prime, what is the value of sigma x prime? Let me change the color. We know sigma x prime, it is sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 cosine of 2 theta plus tau xy sine of 2 theta. But remember this, all of them we kept them as constant, right? The stresses sigma x, sigma y and tau xy, they are constant, okay. So for sigma x prime to be maximum at some theta, we know delta sigma x prime divided by delta theta, it has to be 0, right. So all of this has to be, the differentiation of all of this, right, has to be 0, okay. So d by d theta of all of this, so let me just copy and paste it. All of this has to be 0, okay. Now it will distribute to each term, okay. So differentiation of this thing, it because it is only a constant, so differentiation of a constant is 0, so it is going to be 0 plus, now it is sigma x minus sigma y by 2 is constant, but this is variable, right, because theta is the variable, theta changes, okay. So the constant will stay outside and then we will find the differentiation of this, okay. So it is sigma x minus sigma y by 2, and then we have d by d theta of cosine of 2 theta, right. Similarly here tau xy will stay outside, then we have here d by d theta of sine of 2 theta, right. Now what is the differentiation of cosine of 2 theta? It is, we know from trigonometry, it is, or the calculus, we know it is minus 2 sine of 2 theta, okay. Then tau xy will stay outside because it is constant. Then differentiation of this is what? From this calculus we know it is differentiation of sine 2 theta is cosine of 2 theta. It is 2 times cosine of 2 theta, okay. So tau xy 2 times cosine of 2 theta, okay. All of it has to be equal to 0, right? So let us rearrange the terms here, okay. So it is here minus 2 sine 2 theta sigma x minus sigma y by 2 plus tau xy twice cos of 2 theta is 0, okay. Now let us throw this now first of all this 2 and 2 will cancel out, right? This 2 and 2 will cancel out, okay. Then let us throw this thing to one side, so the negative will change to positive, okay, and they will equate, okay. So it is sine 2 theta sigma x minus sigma y by 2 is equal to tau xy cosine of 2 theta, right? Now let us throw cosine of 2 theta to this side, okay. So it is going to be sine 2 theta divided by cosine of 2 theta, it is equal to, let us throw this term to this side, it is going to be tau xy divided by sigma x minus sigma y by 2, right? Now because we equate it to 0, right, we equate it to 0, we equate this to 0. So what is this theta? This theta is theta p now. Why it is theta p? Because differentiation, we equate the differentiation to 0, and we know when we equate the differentiation to 0, this theta is going to be what? This is going to be maximum, the stress is going to be maximum, if you see here. Yes. Now when we put this term to 0, so it is going, this sigma x prime is going to be maximum, okay. And we know the when the stress is maximum, we call it as principal stress, and the theta, what we call it as, the theta we call it as theta p, right? So this theta is basically theta p, right? Theta p, right? Now sine theta divided by cos theta, or sine 2 theta divided by cos 2 theta is tangent of theta, right? Or tangent of 2 theta, okay, is tau xy divided by sigma x minus sigma y by 2. So we found the value of theta, okay. So we found the value of principal angle, right? So we found this, the principal angle. So wherever you have, whenever you have a question, okay, for example, let us say this is 80 megapascal, let us say this is 60 megapascal, okay, let us say this is 20 megapascal, and you are asked to find the value of theta at which there is maximum stress on any plane, okay. So if you want to find this theta, right, so this theta p can be found from, because it is the maximum, right? So this is going to be theta p. So if you are asked to find the theta at which you have the maximum this stress on this inclined plane or the principal stress, you will use this equation, okay. So this will give you the angle at which this plane exists, right? Now here is a twist. Now we can also denote this with minus and minus, right? Because minus and minus will cancel out. So it means there are going to be two values of theta p, okay. There is going to be two values of theta p, okay. So if we draw this on a triangle, okay, let us say this is positive y axis, okay, and let us say this is positive x axis, okay, and this side is the negative and this side is the positive, right? This is the bright side and this is the cold side, right, the dark side, okay. So now what is tangent of something? Tangent is, in a right angle triangle, tangent is perpendicular divided by base, right? If tan of 2 theta p, let us say this angle is 2 theta p, okay, because we will have two values of 2 theta p. First is negative divided by negative, and another is positive divided by positive. Okay, so we will have, this is the positive tan theta p, and from here we will get the negative 2 theta p. Okay, so you can see this, they are 180 degrees apart. Okay, so 2 theta p1 and 2 theta p2, I call this as theta p1 and theta p2. Okay, so they are 180 degrees apart, as you can see from here. Okay, so it means if we throw the 2 to this side, right, so it means theta p1 and theta p2, it is 180 divided by 2 is 90 degrees. So theta p1 is theta and theta p2 are 90 degrees apart. What does it mean? It means there exist two planes. Okay, they are at an angle of 90 degrees. Okay, it doesn't have to be perfectly horizontal and vertical. Okay, it can be anything, but the angle between them is always the 90 degree. Okay, so if this is the plane where we have the principal stress 1 or the maximum principal stress, and then there will exist another complementary plane at an angle of 90 degrees where we will have maximum principal stress. Okay, so if we have, for example, sigma p1, so it automatically means here it is going to be at this plane, here is going to be sigma p2. Okay, and the angle between these, principal planes is what? It is 90 degrees. Okay, so now we know, because of this theta, I told you before, we will find the planes, so we also found the planes here. Okay, so we found the principal planes too, and we basically have two planes where one plane have what? Maximum principal stress, and the other plane have minimum principal stress, and the angle between these two planes, right, is what? 90 degrees. Okay, now we found the principal angles, we found the principal planes. Now let us exactly found the values of principal stresses. Okay, right now we only saw what? We only saw there will be some planes, there will be some theta at which we will have maximum and minimum, or at which we will have principal stresses. Okay, and we found the value of theta p. Okay, how we found the value of theta p as tan of 2 theta p is tau xy divided by sigma x minus sigma y divided by 2. Okay, from this we found the value of theta p, right? Because if you have this tau xy and sigma x sigma minus sigma y, you can put them in the calculator and you will get the value of theta p. Okay, now what is the value of sigma p1, right, or sigma p2, right? So let us find it. Okay, so we know at theta equal to theta p, sigma x prime is going to be what? Sigma p, but it is going to be sigma p1 and sigma p2, right? Or we can just right now we call it as sigma p, right? At theta equal to theta p, we will have this sigma x prime will be sigma p. Okay, but we know sigma x prime, what is the value? It is sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 cosine of 2 theta plus sigma x minus sigma tau xy sine of 2 theta. We know this, right? We know from the beginning, right? But at theta equal to theta p, so if we put theta equal to theta p, if we put theta p here, this is going to be what? This will be what? This will be now sigma principal stress, right? Because we put theta p here, right? So let us put the value of cosine of 2 theta p and sine of 2 theta p. Okay, we know we found the relation tan 2 theta p is tau xy divided by sigma x minus sigma y by 2, and in the geometric form, if we write it as, it is going to be like this, right? This is going to be tau xy, these two things, right? And these two things are going to be sigma x minus sigma y by 2, and this is going to be sigma x minus sigma y by 2. Okay, now I told you why I write two things, why I made two triangles, why I didn't make only one right angle triangle, why I made two right angle triangles. It is because we can also write negative here, right? so there will be the negative side too. Okay, so this thing is the negative side as I have told you, and this is the positive side. Okay, this is the positive side. Okay, now anyways we have to find the value of cosine of 2 theta p from this triangle, right? So this is 2 theta p and this is 2 theta p. Okay, now from from trigonometry we know sine, we have to find cosine of 2 theta p. It is going to be, what is cosine of an angle? It is base divided by hypotenuse, right? What is the hypotenuse? Hypotenuse is square root of perpendicular square plus base square root, right? So the hypotenuse is sigma x minus sigma y by 2 whole square plus tau xy whole square. Okay, so the cosine is base divided by hypotenuse. It is sigma x minus sigma y by 2. It is the base, right? It is the base. Okay, and the hypotenuse is sigma x minus sigma y by 2 whole square plus tau xy whole square, right? Similarly, sine 2 theta p, because we also need the value of sine 2 theta p, right? It is what? It is, what is the value of sine? Sine is perpendicular divided by hypotenuse, right? So it is tau xy divided by square root of sigma x minus sigma y by 2 whole square plus tau xy whole square, right? Why? Because this is the hypotenuse, right? This is the hypotenuse. So perpendicular divided by hypotenuse is sine 2 theta. Okay, so let us put these values here. Okay, so what we get? So we get sigma prime is, first is sigma x plus sigma y by 2 plus sigma x minus sigma y by 2. Now cosine of 2 theta p, I will put this value here, divided by square root of sigma x minus sigma y by 2 whole square, right, plus tau xy whole square. Then we have what? We have plus, right, plus tau xy sine 2 theta p. Sine 2 theta p is here, it is 2xy divided by square root of the same thing, right? Square root of same thing. Okay, so sigma p is going to be sigma x plus sigma y divided by 2 plus, now this is sigma x minus sigma y by 2, sigma x minus sigma y by 2, so it is going to be sigma x minus sigma y divided by 2 whole square, right? Then it is plus tau xy. Okay, then this square root thing is common, so I will put square root thing common, right? Sigma x minus sigma y divided by 2 square plus tau xy square, right? Now it is what? Sigma x minus sigma y by 2, right? Because if you remember, it is whole divided by 2, right? It is whole divided by 2. Okay, so it is same thing. It is like, if we call this as a, okay, if we call this as all of it, if we call this as a, right, if we call this as a, then this thing is going to be what? This is going to be square root of a, right? So all of this term, it is a divided by square root of a, and we know from basic mathematics, a divided by square root of a is plus or minus square root of a. Okay, so this sigma p is going to be sigma x plus sigma y divided by 2, then this, right? And it is, what is a? A is this, a divided by square root of a is plus minus, right, under root of a, right, square root of a. What is square root of a? Square root of a is this, right, divided by 2 whole square plus tau xy whole square. Okay, so here we go, we found two values. First is this plus this term, then other is this term minus this term. Okay, so it is, we got two values of sigma p. Okay, so these two values are sigma p1 and sigma p2. Okay, so sigma p1 related to the plus sign, okay, sigma p1, and this minus term relates to sigma p2. Okay, so we have the maximum principal stress, right? So from it, what we have maximum, but basically it is in plane. I will tell you in a moment why we call it as in plane. maximum in plane principal stress, right, and we have minimum in plane principal stress. Okay, so what is the value of this thing? Wait, let me put it a bit down. Okay, so we have two values. Now what is the maximum principal stress? It is sigma p1, it is equal to sigma x plus sigma y divided by 2 plus, right, the plus square root of sigma x minus sigma y divided by 2 whole square plus tau xy whole square, right, and we have the minimum in plane principal stress sigma p2, it is equal to sigma x plus sigma y divided by 2 but minus, right, minus square root of sigma x minus sigma y divided by 2 whole square plus tau xy whole square, right. So we have these principal stresses, right. Now I told you earlier, I will tell you why I write this in plane. Okay, so why I write it in plane? Because we are rotating the inclined plane within the same plane. Okay, and these principal stresses, they lie in the same plane. For example, if we have this body, okay, if we have a for example, if we have a stress like this and stress like this, and we also have a shear stress like this, right, so there will be some plane, but it is also going, this sigma y and tau xy and sigma x, it is in what plane? It is in xy plane. Okay, so in the same xy plane there will be some at some angle, okay, where we will have this principal plane, right, but in the same plane, and there will also be another principal plane at angle of 90 degrees, right, but all of them, they will be in the same plane. So that is why I use the word in plane. Okay, so this in plane and in plane, now you understand why I write in plane stresses. Okay, so now we found the maximum and minimum stresses. Okay, so we found these values of stresses too. Okay, so now one more important thing is, for example, we know this plane, right, so we know this plane, there will be maximum stress on this. For example, let us talk about only one plane. So we know this plane, it is, for example, let this be principal angle, so it means this red is a principal plane. We have what? We have stress sigma p. Okay, but now the question is, what is the value of shear stress on this principal plane? Okay, now let us find the value of shear stress at theta p. Okay, now it is very simple. We all already know how to find the shear stress on an inclined plane, because after all, a principal plane is also an inclined plane, right? So we will just simply put the value of theta p, okay, from this relation, okay, from this relation, right, into the shear stress. Okay, so let us find. Now we know tau x prime y prime is negative sigma x minus sigma y by 2 sine 2 theta plus tau xy cosine of 2 theta. Okay, now we are talking about principal plane, so we will put theta p here. So when we put theta p here, so we are shifted to the principal plane. Okay, so this stress is right now what it is, the shear stress on the principal plane. Why? Because we put theta p here. Okay, so let us put the value of sine 2 theta p and cos 2 theta p. We already know these are the values of sine 2 theta p. Where is it? These two, right? So these two values, right? So we know these values, right? So this is the cosine of 2 theta p, right? So let me erase these things. So let us put these values here. So it is going to be minus sigma x minus sigma y divided by 2. Sine 2 theta p is this, tau xy divided by square root of sigma x minus sigma y by 2 whole square plus tau xy square plus tau xy. Cosine of 2 theta p is this, right? Divided by square root of the same thing, right? Square root same, right? Now it is tau xy times this, right? So it is minus sigma x minus sigma y divided by 2 tau xy plus again sigma x minus sigma y by 2 times tau xy, right? 2 xy, and this square root thing will be common, right? So this square root of thing is here. Now this is 1, it is negative, sigma x minus sigma y by 2 tau xy, it is the same, right? Product of the same two things, okay? It is plus, so minus and plus will be 0, okay? So 0 divided by something is 0. So what does it mean? The shear stress is 0. So it means shear stress on a principal plane is 0, okay? So we know the shear stress on a principal plane is 0, okay? So let me now summarize everything, okay, from this class, okay? So we know, let me write this. So if it is sigma x, if it is sigma y, right? If it is tau xy, okay? So let us say this is x axis and this is y axis. So add some theta equal to theta p. This is the principal plane, right? This is the principal plane, right? Why it is principal plane? Because it is inclined at an angle of theta p, right? So this theta p is principal angle, right? But we know wherever there is principal plane, there is also going to be, the other plane on this which is at an angle of, for example, 90 degrees, right? This is what we learned, okay? So there will be two principal planes, okay? So they will be two principal planes and separated by what? Separated by angle of 90 degrees. With 90 degrees, I mean not separated, at an inclination of 90 degree to each other, right? So there are two principal planes. So where we have, we have sigma p1 and we have sigma p2, okay? So it is at an angle of theta p1, okay? So this is at an angle of theta p1, okay? And this thing is at an angle of theta p2, okay? And we know the angle between them is what? 90 degrees, okay? So this thing is at an angle of theta p2, okay? And we know what is the value of tan theta p. Tan of 2 theta p, it is tau xy divided by sigma x minus sigma y divided by 2. And if we show them, using triangles, we can also write it as negative, because negative and negative is again the positive, so it is one and the same thing. So we can show it like this, right? We can show this relation like this. So this is sigma x minus sigma y by 2. This is also sigma x minus sigma y divided by 2, right? So this is 2 theta p and this is 2 theta p, okay? The angle between them is 180 degrees, right? They are 180 degrees apart, so it means the angle between theta p1 and theta p2 is 90 degrees, okay? Now we found this tan theta p, right? Now what is the value of sigma p1? The sigma p1 is sigma x plus sigma y divided by 2 plus square root of sigma x minus sigma y divided by 2 whole square plus tau xy whole square, okay? Then we have sigma p2, it is sigma x plus sigma y divided by 2, but minus here it was plus, here it is minus, that is the only difference, right? Sigma x minus sigma y divided by 2 whole square plus tau xy whole square, right? So this sigma p1, it is called as max in plane, principal stress, right? And this thing is called as minimum in plane principal stress. Okay, so this is the summary of this class. Okay, so now in the next class we will solve some numerical problems, okay, on the principal stresses. Okay, and yes, one more thing, we learn one more thing, that shear stress on principal plane, right, principal plane is 0. Okay, so tau x prime y prime is 0 at theta equal to theta p. Okay, so these are the things that we learned. Okay, so in the next class we will solve a problem, okay, and then I will also provide you a homework problem to you practice. Okay, we will solve the problem on the maximum and minimum in plane shear principal stress. Okay, so that's it for today. See you in the next class. Thank you.